to the DeepTech Talk, a tech podcast presented by BIS Research. Today, I'm your host Jaya, and I have with us Sayam, Dhruva Jyoti, and Neha to discuss on the horizons of electric vehicle batteries. So, as I talk about electric vehicle batteries, the first thing that comes in my mind is the lithium-ion batteries. I would just I'd like to ask that what is your opinion on trying other battery materials except for lithium ion? Of course, it's a tried and tested material, but what do you have your own thoughts about trying another a new unproven materials? Will it be adventurous or
Right. I will like to pitch in first. Lithium ion obviously is one of the most dominating battery chemistries right now, especially in Western countries, including North America and Europe. The reason for it being that till now, for all the different type of chemistries which are being experimented upon, whether it be nickel metal hydride, any type of nickel combination, solid state, or sodium combination, sodium ions. Lithium ion has proved to be the one which has a ease of manufacturing and a ease of procurement from the terms of raw material, and that is one of the most important part. So, for example, if we look at alternative battery chemistries like solid state batteries, so obviously it has a much more better energy density because literally it has a solid electrolyte instead of most of the liquid electrolytes in different other chemistries including lithium ion. But the main problem with solid state and other battery chemistries is mainly due to the commercialization. The cost of manufacturing and the cost of manufacturing at scale is very, very high right now, and it would take some years. So, for example, one of the leading companies which is manufacturing solid state batteries right now, they only have a capacity of around 200 tons, which is way, way lower for a general adoption. So there are some companies like, for example, Toyota has announced that they will look into solid state battery models to be released by 2027. Then there are other experimentations going on, including lithium sulfur, NIMH, and so on. But I think personally that is still a few years to go from now on, at least 4 to 5 years. And lithium ion is currently the best option. And apart from that, another major chemistry which has been adopted widely is lead acid. But then lead acid is something which has its own disadvantages in terms of thermal runaway, in terms of the overall energy that is being produced. Obviously, right now, I think at least for the near future, lithium ion is going to prevail.
Just to continue with what Dhruva Jyoti has just said, it's not only about experimenting with the new chemistries, it's about the need of the industry as well, because there are a lot of concerns with respect to lithium-ion batteries. It starts from the sourcing of raw material, because there are various challenges in sourcing the raw materials, some of the key materials for lithium-ion batteries like cobalt. There are some ethical issues in sourcing of cobalt in Congo. Then similarly for graphite, it's mainly countries are dependent on China for that. So there could be various risks going forward in terms of supply chain. There would be supply chain concerns. There would be dependency on few countries. So therefore, solving all these problems and to continue the high adoption of EVs, we need to certainly experiment with new chemistries, and that will solve the problem.
Also, to add on to it, lithium ion has seen this abrupt changes, or maybe say the trend of use of lithium ion started when in early 1990s the Nobel Prize was awarded for the lithium ion chemistry batteries, and then the focus shifted to lithium ion batteries. But yet again, there are various other chemistries in the market which can be focused, but they are not researched upon at that scale. Few to mention are like calcium can be used, magnesium can be used. And as my colleagues were earlier mentioning, the disadvantages of having lithium. So the biggest problem with lithium is once the battery is formed. So it's basically a flow of lithium ions between the electrolytes, right? So what happens is on the electrode, the dendrites forms, which actually tend to busting of the battery and causing a fire. And we have seen various multiple scenarios in which like Ola Electric has got a vehicle busted because of the same instance. So certain instances in this particular battery life will definitely provide a new era to it. And also there is a research going on flow batteries, then we have saltwater batteries. So we are seeing a monotonous increase in various other types of batteries and chemistries that would definitely change the concept of lithium-ion batteries. Not in coming 5-10 years, but yes, in future, definitely.
Okay. So as you talk about Toyota and other big companies, of course, but if we talk about the startups, what would a startup has to be concentrating? What would be the initial concentrations and the objectives of a startup to come into the EV batteries?
Well, from let's break down from supply side and demand side both. Right. So from supply side, if I'm a startup, so in the past few years, more than $230 billion worth of investment has been done for electric vehicle batteries. Right. Most of these investments have been done with either in collaboration with big OEMs, big MNCs, or companies who have deep pockets. Right. So if this is a mainly a new startup, I would generally suggest to focus on R&D, because from the supply side it's a very expensive process to establish yourself as a major player. The cost incurred within the value chain differs from sourcing, from mining, from manufacturing at scale, and also since we are talking about electric vehicles, which to be honest is still a very nascent technology, at least in terms of adoption in majority of the markets. So companies, OEMs, EV OEMs don't want to risk to give their long-term contracts to just nascent startups. So to establish a lot, mainly most of the startups that we have observed over the years, they have started with R&D process, right? So getting into a unique IP, right? Getting properly funded, and after that moving into the bigger space of manufacturing for actual electric vehicles. When we talk from the demand side, if I am an electric vehicle manufacturer, so there is a lot of potential in, for example, in India specifically, we have seen a growth of startups which are focused on electric vehicles, whether it be small commercial vehicles or vans, or whether it be electric vehicle scooties, right? So a lot of startups are involved. So I think from the demand side, it would be much easier because there is also a trend now in terms of cost saving for logistics or for their inventory management. If they have an electric vehicle fleet, it's much more easier for them as compared to general internal combustion engine vehicles. So yeah, so from demand side, I see a lot of startups investing into EVs. From supply side, straight away getting into the game would be a bit tough. So the main point of entry would be from R&D. That is my opinion.
And in a nutshell, if we talk about startups coming in the market, so they need to focus on solving the existing problem with the chemistries on like lithium ion or solid state. There are some concerns with this. So if startups can focus on solving these problems, securing a sustainable supply chain, and if they can get into some collaborations, that will be a great start for them. And if because at initial level it will be really difficult to start with, and then as Dhruva Jyoti mentioned, start at that stage R&D will be crucial, and along with R&D they need to form up tie-ups also, and it can be with the electric vehicle manufacturers, it can be with the other startups coming in the market. And another very important part would be to secure a funding for that, because it is a very costly business to enter into. Because it can't be like you just developed a prototype, then you need to secure a long-term supply chain for that. So for that, it can be like either it can be from angel investors or any other source of funding, but funding would be very crucial for them, because as I mentioned, they need to secure supply chain, because this is the major problem with all the battery chemistries at this moment.
Also, a very big point of concern here would be who would be the customer, because not everyone is liking to go for electric vehicles as their first choice.
Yeah.
Certain problems are associated with it, and also in which geography all over the world these startups are pushing themselves to, because not every geography is infrastructurally so strong enough to put electric vehicles on par. So definitely startups have to think on ground with respect to the technology they are targeting on, what kind of new thing that they can come up with, because companies like I can mention BMW come up with their own system for it. Then we have Tesla, they have tried and tested their autonomous manless vehicles. So the big players are actually putting their all on the table. So startups have to come up with something completely different out of the box and with acceptance of the customer, because at the end of the day, customer will be driving the demand and creating their presence in the market and not anything else. So that would be one point.
And just to add on to another point, apart from the supply chain or the battery chemistries, the startups needs to form some alliance or collaboration with the battery manufacturing equipment suppliers also, because in the industry we have seen a trend that companies are getting into long-term agreements with the battery manufacturing equipments or suppliers. So if somebody has developed a chemistry or something, but to get it to a scalable or profitability scenario, they need to form alliance with the manufacturing equipment side also, because apart from the raw material for the battery, there has been a snarl with respect to manufacturing equipment as well.
So, as you said, collaboration. So, one school of thought is that startups should collaborate. The other is that they should compete also. So, where do you guys stand in this dilemma of collaboration versus compete?
At this time, collaboration is the need of the industry, because if startups will collaborate, this will allow them to efficiently develop new chemistries.
Yeah.
And it can be sharing the resources as well, sharing the expertise and everything, because everything cannot be about competition. And when we are talking about the sustainability side, and there are various regulatory bodies also involved in this market, which are emphasizing on developing a sustainable supply chain. So for this, I think collaboration would be go-to strategy in the initial level, and then later on it can be about competition towards commercialization, because if some companies have formed a collaboration to develop their chemistry, they can take advantage to get their market share later while commercializing their product.
I personally think that collaboration and competition can go hand in hand, because while collaborating, if you are a startup and you develop something new, the team you are collaborating with can actually hamper the production that you came up with. Maybe you came up with new technology. So if you are collaborating with some giant, they will totally shadow your production and you can be of no use with your very sound development. So what happens in this scenario is, as per my thought process, the startups, when we are talking about collaboration, they must collaborate. I'm not denying the fact. But there should be a limit to the extent of what collaboration it is. They can maybe collaborate together in building technological advancements, doing the R&D analysis. But yet again, competition is the key to new developments. If there is no competition, I don't think the market can actually develop at that pace. So if we talk about competition, then certain aspects like maybe new designing, new advancement in technologies, or crafting the new battery chemistries, these could be kept at a level of competition rather than collaboration. So we can take both the things hand in hand for the development of the market.
But at the same time, I feel like I agree with Neha that it should be hand in hand collaboration versus competition. But I believe like it's a very tough market to enter. It's a very cost intensive. Startups will need a lot of funding, as we previously discussed. So at the entry level, I suggest it should be collaboration, and then later on, as Neha mentioned, it should be towards competition. What are your thoughts?
Yeah, obviously. I mean, for startups, see, competition will always be there if you're in a business, right? The point here is that if collaboration should be the key or not. See, owning or being functional in the entire supply chain or value chain of the entire EV battery, it would be very difficult for even big companies, let alone startups. Right? As a startup, mostly the companies that we have observed, they are into niche segments. They are focusing on a particular technology, on a particular product or a sub product. So of course, all of these companies are looking for collaboration. That's the need for them, for both in terms of funding, both in terms of clarity of their project, and for sustainability into the market. If you are not collaborating, if you have a product but nobody is going to collaborate with you and pick your product, obviously as a startup you are going to die down, right? Your funding will eventually run out. So it is important for every startup to collaborate. So I don't think even any big companies are there which are there from in the entire value chain, right from mining to shipping it to the OEMs and recycling and so on. So obviously all the big players, especially startups, it is essential to do.
So, as we move forward with the battery composition, battery chemistry, and everything, there comes the concept of battery repurposing. So, what do you think? What are your thoughts on that? That whether it have any potential risk factors also, or is it completely safe for the battery repurposing?
It's not completely safe also, but at the same time it's an important aspect because the resources, the raw materials required for battery manufacturing, these are not infinite. There is a limitation, and that too companies are dependent on few countries. So second use batteries or battery repurposing is a very important part in the overall value chain. But at the same time we need to see like where we are going to use it, because there are certainly some hazards towards it. It needs to be properly maintained. What kind of chemistry it is which is going for the second use life. All these factors needs to be thoroughly checked. And then because at the same time there is a huge focus on recycling also, because if we'll send a battery towards second use and after that it will go for recycling, then there will be a challenge of collecting the batteries for recycling. Because it can majority of the batteries used in EVs will go for stationary energy storage, and then from that point getting it for recycling is a concern mentioned by various companies. So I think it's an important part, the second use thing, but there needs to be proper standards for that. There needs to be proper channel of distribution and collecting the batteries for recycling.
Right. From a repurpose point of view, as Sayam mentioned, so for stationary energy storage, obviously, for the repurposed point, that's one of the key applications for EV batteries. So that market, as per our analysis, is also supposed to grow infinite at a very good rate. So I believe currently the market is around 30 plus billion, and it will grow up to 110 billion plus within the next 10 years, right? So that itself shows the potential as to how much battery repurposing is going to grow. Now when we come to the overall need of it, right, we are replacing internal combustion engine vehicles with EVs. One of the fact is that crude oil is it's not an infinite resource. It's a limited natural resource. But we also have to realize that the elements that are utilized for electric vehicles are also natural resources. The lithium reserves, the nickel, manganese, cobalt reserves, they are limited on Earth, right? So it is very, very important for us to repurpose and recycle them, right? Because without that, eventually we will have the same dilemma that we have with internal combustion engine vehicles. Now, the point with electric vehicles is that of all the various materials or metals being utilized for the electric vehicles, even with the general, at the end of a general life cycle, let's say around 10 years or 8 to 12 years of an electric vehicle, all the metals are reusable. 99% of the minerals or metals in an electric vehicle are reusable. So why is there a need to simply dump them in a landfill when the electric vehicle is out of use? We can simply utilize that again, and that's why we are seeing a great growth in the number of companies and in the number of investment that is growing into electric vehicle recycling and repurposing. So there is a great potential, right? The process might still have a few more touches before it becomes more profitable or more manageable or scalable. But certainly companies are already looking into this, because if you are investing billions of dollars into sourcing that mineral and you are part of that supply chain, it is very, very logical that you repurpose that very mineral, and at a fraction of a cost you can get it back into your supply chain again. So yeah, so it is important.
To add a point into it, so when we are talking about second life batteries, so the very big thing is why we are actually taking these batteries to second life. So electric vehicle, the main purpose of battery is provide efficiency. So over the time, the battery degrades that efficiency. But yet again, it is very good for storing and providing energy back. So that is why instead of recycling, we're thinking of reusing that batteries into stationary energy storage, because their performance is not the key, their storage is key. So one sort of performance is degraded, but another aspects can be yet again used to sustainability in this particular market. So that is one thing why we are using second life batteries. But then there come hazards with it. For example, there could be batteries which have been just utilized and never been rechecked or have gone through assessment in their life ever again. So there are certain hazards that come with it. So for those to mitigate such hazards, I think there should be certain regulatory standards that could be put up, and there should be a completely neck-to-neck check on the batteries that are used in these kind of stationary energy storage. And this particular field, if it has been checked, it will provide a boom to the renewable energy storage market as well. Because for that we need battery, and if we have readily available batteries, because after 8 to 10 years, every electric vehicle has to go through a change of battery. So where that lot will go? Everything recycled, yet again it will have the cost of recycling also. But if it can be refurbished at minimal cost and utilized into the market, under the system again, and if it can create wonders, why not? So that's just one thing.
Of course. As you're talking about the resource and consumption of the resources, recycling has been playing a vital part in the sustainability, of course. Right. So, what do you think? Is it that effective recycling procedure and effective recycling would anyway be a sustainable option, or is it just a band-aid solution to resource consumption?
No, it is certainly a sustainable solution. So, for example, as I mentioned earlier, right, many companies are looking into this. So, for example, Tesla's I think VP or CTO, right, he founded a company specifically on EV battery recycling, and that is about to reach a valuation of $5 billion in its latest startup funding. So there are various methods which are being utilized right now. For example, one of them is direct recycling, right? So the point is, let's suppose if I have a NMC battery, okay. So earlier, what is supposed to happen is that you differentiate you extract the various elements, right, from that, and you break down the battery into elements, and then utilize that element again through the entire process to create a separate battery. Now, through direct recycling, what you can do is you can simply extract the MNC as a whole. You don't have to get the different elements separately. So what it does, it saves you cost. It makes the process more direct, and in fact, more energy efficiency is also proven to be there. So these type of methods are obviously more sustainable, for the future. As during our previous questions discussion, Neha mentioned. So a lot of companies, are also looking, because it is important, right? We have various, and let's not just focus on passenger vehicles. There are batteries being utilized on two-wheelers, three-wheelers, which has a great adoption within Asia Pacific countries, specifically China or India. So these type of batteries also, if they are utilized, they contribute a lot to the overall cycle. So the point is that recycling enables a circular economy within the entire ecosystem. And a circular economy in itself, within its sense, provides a much more economic stability for the overall supply chain players, and also provides a term some of sustainability within the overall process of manufacturing for electric vehicles. So, from ecological point of view, from monetary point of view, from mass of scale point of view, recycling makes sense in every way. So that's why so many companies are adopting this.
And just to add, it's definitely sustainable and most important thing in the supply chain, the recycling part, because companies don't want to don't want to take the risk of running out of the supply of materials. And it's not only about increased adoption, it depends on the geopolitical scenario also. So, because these resources used in batteries are not globally available. Like there are some, like copper is worldwide available, but there are some resources, like I initially also mentioned about cobalt. With cobalt, the thing is it's majorly present in Congo, and there are various ethical concerns with the mining of cobalt. They are using child labor, and other concerns are there. At the same time, graphite. Graphite is a key material for batteries, but graphite is majorly found in China. And we have seen previously also China-US trade war. It could be anything, so that can hamper the supply chain of batteries. Similarly, we have recently witnessed the Russia-Ukraine scenario. So for lithium, Russia and Ukraine are one of the key sources for lithium. So having any geopolitical scenario concern can create the risk of it can affect the supply chain. This can create some difficulties for companies. So if companies in different countries can adopt the recycling part, they can make them more dependent. They can make them more profitable. So this will be a very efficient solution. And in the long run, when we are talking about the mass adoption of EVs, it will surely mitigate the risk of supply chain stuff.
For this, I have for me, it's like two sides of a coin. So, as Sayam already mentioned about Congo. So, here I just want to add a point. China is actually have taken hold on various mines all across the world. So that is why they are actually having the hold on 80% of the reserve that are being used, basically metal that came from mining and being used in the batteries. So a country is a leader of it. So yet again, every other country across the world is finding a solution towards it. How they can also have that reserve with it. Right now, if you talk about it, if we talk in terms of black mass, so black mass is nothing. It's the first, once the battery is recycled at first stage, it is converted into a powder which is known as black mass. So if you currently study the scenario of black mass in European Union, it's in abundance. It's there, it's present, but there is no recycling technology. Or people are actually failing at that. Why is this happening? So the very worst reason why recycling right now is not able to boom that is, we have multiple battery chemistries, and each chemistry require a different set of recycling, which companies are not able to provide. So at this scenario, what happens is not every chemistry can be recycled with the same technology. Hence, there is an abundance of black mass which is present in European Union right now. And then there are regulations that come with transporting this material. So we can say it's a powder material, we can definitely transport. No, we cannot, because lithium is hazardous in nature. So hence we cannot transfer it. And there are regulations that you cannot transfer lithium by air or by water. So it has to be recycled in the country where it is present. So that creates a problem with the recycling. If we talk about the developed countries and the countries which have those manufacturers or recyclers in there, Yes, they can do it, but what about the rest of the world? The technology has to be advanced and to be created all around the world when it comes to recycling. So that's why I say right now it's just a band-aid solution what we are doing it, because we are not having the clarification at the end of what recycling has to be done. But yet again, if we talk about a decade or so, we have a growth rate of more than 25% when it comes to black mass recycling or battery recycling. Yet again, it can actually transform completely. Like China today is holding the economy for recycling, but yet again, we can completely see a swap in coming decade because of the hold on how the development of technology act and how fastly people can recycle the ton of material that is being kept in the countries as of now.
So firstly, lithium or other battery chemistries, so countries like China may have a hold on them, but that should not be a limiting factor in any way, right? So if we look at crude oil, so the Middle East has a hold on 70-75% of the production, if not the reserves. So similarly, if you look at semiconductors, right? So from the side of South Korea or China, again there is a concentration of countries who have the highest share. So that is, I don't think, should be a limiting factor to procurement of these raw materials or the recycling of these raw materials. Another point was that the battery recycling market is low right now. It may be perhaps because of the different chemistries, but one thing we have observed is that mainly most of the startups that are focusing and growing, they obviously are not looking right now to expand into all of those different sectors. It makes sense to focus on lithium ion because majority of the vehicles are in lithium ion, right? So they don't want to develop their recycling technologies into 10 different chemistries because the profit or the revenue from the other 9 or 8 chemistries would be very negligible as compared to the top 1 or top 2. So that's what most companies, most startups are focusing on. And another reason for the market being low right now is that currently, because of the adoption of electric vehicles over the years, still 90-95% of the electric vehicles that are ever produced and commercialized are still on road. Yes. So there hasn't been an opportunity for recycling because there are still some years left in even the older EVs. Right? So the market is going to boom. Right, regulations are coming into place, right? And startups and MNCs are obviously, strategizing accordingly. So yeah, I think recycling again has a very good feature.
Just to add another point, from the point of view of adoption of EVs, in various countries there are not very strict regulations with respect to adoption of EVs. The major concern in countries like India, it's the cost of electric vehicles. And in EV, majority of the cost goes into the battery. So if recycling will be increased, then the overall cost of the battery will be lowered. So it will increase the adoption of EVs in countries where it's not at par right now. So overall, if I'm looking from the in the line of like next 5 to 10 years, then recycling has to play a very important role towards the replacement of ICE vehicles in some countries. It won't be full replacement, but at least there would be enough adoption. So for this purpose, I think recycling is here to stay, and it will be a major part of the supply chain and the ecosystem of EV batteries.
Also, to actually have a successful recycling strategies, it's a consumer that has to put into limelight. If you as a consumer cannot understand where your battery is going, then yet again it will again end up in the landfills, which happens with most of the consumer electronics items in which we are using batteries. So most of the batteries end up in landfills. So there is no purpose of recycling them. It's end up there, it gets wasted, you cannot actually go again in the dump and create it out. So there are various companies across the world, they are providing you with an opportunity where you can dump your batteries. Even most of the companies across the world are thinking of creating something called as battery passport, in which they will be keeping a track on whatever batteries they have manufactured so that they can come back to their houses, and those batteries can have a very good circular economic life cycle in which we can have a track where it is using. There could be sensors that can be used on the life productivity of the battery. So we have a very bright future when we talk about battery, and certainly with bright future there are certain setbacks which we definitely have to work upon to make it a successful run.
Okay, so let's kick it up this podcast because it's so I've done last segment. It is a rapid fire segment. Okay.
Interesting.
Yeah. So you just have to pick answer. In some questions you will be picking an answer, a point, your options, and in some part it will be you can share your thoughts and everything. Okay, so let's begin it with my first question. Fast charging or extended battery life?
Fast charging.
Fast charging. What
Fast
will you say?
Fast charging.
Fast charging, of course. Okay, so wireless charging, like wireless charging pads or swappable battery packs?
Swappable battery packs.
Wireless charging.
Wireless swappable. Okay. Do you guys have to say like why swappable and charging pads why?
Because wireless charging also requires you to stay. You don't want to stay.
Time consumption.
Yeah.
Consumption. And it will allow
We
you
don't
the
have that
flexibility.
much time. We require that flexibility to just move ahead in life fast and furiously.
With various people, this is a concern. The charging, the battery life. If we'll have swappable battery pads, then it will remove that limitation from people's mind that they need to invest great time in charging the batteries, or they need to be dependent on that, because a very important part of EV commercialization or EV success is the charging stations. Everywhere it's not present, so this will because in some countries it's a challenge to find a proper charging station, let alone the wireless charging station.
Yes. So what do you think is the most promising EV battery market? Asia or North America?
Asia.
Asia.
Yes.
100% Asia.
Okay. What is the biggest hurdle in achieving 1,000-mile EV range?
The cost size of the battery. It will because right now there are some developments going on with respect to higher energy density batteries in smaller size, but at the moment, especially with lithium-ion battery, it's not possible, and it will significantly increase the cost also with the current battery chemistries. But in the next 5 to 7 years, yes, I can easily see many companies coming up with 1,000-mile plus range.
Also, with larger battery size comes the larger housing circuits.
Yes, that's important.
And with housing circuits, we have a larger thermal management systems. So to maintain that, the vehicle would be very heavy. So first of all, we have to degrade their size before actually putting that into a vehicle.
And it will overall reduce the sitting space, the storage space in the vehicle. So that will also be challenging. So in future, when we see a compact size batteries with great energy density, so that time I can see it. But right now, the size and the cost is
the biggest hurdle.
Dhruva, your points?
Yeah, I mean, energy density is the key because you need faster electrode and electrolyte transfers, right, to increase the range. Now, obviously, with liquid electrolyte within lithium ion, that is not yet possible. That's why chemistries like sodium ion or solid state are being preferred. But as we discussed earlier, they are still under experimentation. So, for example, I mentioned a Toyota model which is coming in 2027. So they have promised a capacity of around 700 or 750 miles, right? So obviously, with further experimentation in solid state battery, we think we can probably reach around 1,000 miles probably in the future.
Okay. Okay, so what do you believe? More EV models, electric vehicle models, or more charging stations? What do we require?
Definitely more charging stations. Because
Charging
this is a
stations are the
challenge.
must.
This is a challenge, and instead of more EV models, I can say there should be low-cost EV models for some countries. But at this moment, my vote is for more charging stations.
Charging stations.
Because if there is no infrastructure, what an EV model will do to us if we cannot charge that model and run it efficiently?
Charging models.
Okay. So coming to my final question, what is the most exciting thing about the future of electric vehicle market?
So for me, the overall future is very bright, and it's not only limited to batteries. And because initially it was adopted because of the sustainability part, but now the electric vehicles can also be run using hydrogen fuel cells. So that is a very interesting aspect going to come into place. It's already there, and it is expected to increase. And then now there is going to be competition from ICE vehicles also, because earlier there was no alternative and people were only promoting electric vehicles. But with the recent developments, especially the biofuel alliance G20, so there is going to be focus on sustainable fuel for ICE vehicles. So that will be an interesting part to see. Like, will it lead to electric vehicle companies in reducing their prices, or what is going to be their strategy in continuing increasing their adoption rate?
Right. I think the most exciting parts would be the range, the safety, and the cost, right? Because they are improving over the years. So, for example, if I buy a EV today, right, if I'm driving in the city, it's fine, especially in a city like Delhi. But if I'm in a tier 2 or a tier 3 city, I might get a bit afraid, if there are enough charging stations here and there. So, if in the future, if let's say I can take a drive from Delhi to Shimla or Delhi to Jaipur without charging even once, right, that is the level of charging capacity that is available in my vehicle. So that itself gives me the confidence to buy an electric vehicle instead of an ICE vehicle. Secondly, when it comes to safety, obviously an engine can also burst, but many people are afraid that a battery is more prone to bursting. So there are technologies like immersion cooling, there are various insulations coming in, right? Refrigeration technologies are coming in. So making a battery safer ensures that people have confidence on the overall technology, that it will last for them, not only in terms of accidents also, but like a general lifetime of, let's say, 8 years, 10 years, 12 years, that it will hold for whatever they invest within that electric vehicle. And talking about investment, right now, if I'm looking into electric vehicles, right, most of the, like, if let's say in India, if I have a budget, let's say within 10 lakhs, I don't really have many options for electric vehicles. I have to spend a lot to get a good electric vehicle, right? And even in US or Europe, right, the newer Tesla models and all, they are pretty expensive compared to other hatchback options available for internal combustion engine variations, right? So the day a consumer is able to get a similar or lower choice, lower cost choice for these type of vehicles, then obviously it, not only the high end segment, but mid range and lower range segment consumers will also adopt. So that those are like the exciting things that I would like to see in the future of electric vehicle.
For me, till date, EV has been already an exciting, because the pace at which EV has grown, nothing else has grown, I think, in the past decade. When we talk about comparative analysis on the transportation took eras to transform. ICE took eras to transform. But when we talk about EV, it is like we just talked back few years back, and now we are seeing it as a reality. So this is something which is already exciting, but how technologically advanced it could be in future, and of course how affordable it to be a common man, that would be very exciting to see. And as already Sayam mentioned, that with the coming up of alternatives in the market, where the price will drop, is the best thing that we can see for a common man, in a common man's perspective. Because not everyone can afford a car, but again, if we talk about the levels of unity in the global world, then at least a middleman should. So that would be very interesting to see, like in countries like India, Pakistan, Bangladesh, or our neighboring nations. We would be very likely to see where it ends up in the third tier city and not in the metropolitan. So that would be the journey which would be definitely lovely to be traced.
And that concludes an electrifying episode on EV batteries on DeepTech Podcast presented by BIS Research. I thank my guests Sayam, Dhruba, and Neha for giving us valuable insights on electric vehicle batteries and more. Until next time, this is your host Jaya signing off from the DeepTech Talk.